online lecture series. Myself, Reema Rawat, from LG Institute of Engineering and Technology. In previous session, we have started the unit Network Security. We have seen the topic cryptography. What is cryptography? Why it is required? What are the different systems or what are the types of cryptography? And what is the encryption model that we have seen in the previous session? Now in today's session, we are going to see the next topic, that is symmetric key algorithms. We are targeting two symmetric key algorithms in today's session. First one is DES and the second one is AES. Here DES stands for Data Encryption Standard and AES stands for Advanced Encryption Standard. So let's start with that. So let us start with the first one, that is Data Encryption Standard. So the Data Encryption Standard is a symmetric key block cipher published by the NIST, that is National Institute of Standards and Technology. Ciphering and deciphering means the encryption of the data and decryption of the data and the logic for that. Here in this diagram, the Data Encryption Standard is indicated. So first of all, let us understand what is DES exactly, and then we will see what this exactly does. So in January 1977, the US government adopted a product cipher developed by IBM as its official standard for unclassified information. This cipher is called as DES, that is Data Encryption Standard, was widely adopted by the industry for use in security products. It is no longer secure in its original form, but in its modified form it is still useful. Let's see how DES works. So in this figure, the outline of DES is indicated. Plain text is encrypted in blocks of 64 bits, yielding 64 bits of ciphertext. The algorithm, which is parameterized by a 56-bit key, has 19 distinct stages. The first stage is a key-independent stage or key-independent transposition on the 64-bit plain text. The last stage is the exact inverse of this transposition of the 64-bit plain text. The leftmost 32 bits with the rightmost 32 bits. The stage prior to the last stage exchanges the leftmost 32 bits with the rightmost 32 bits. The remaining 16 stages are functionally identical but are parameterized by different functions of the key. The algorithm has been designed to allow decryption to be done with the same key as encryption, a property needed in a symmetric key algorithm. These steps are just run in the reverse order. So here in the figure A, general outline is indicated for the detail of iteration or the DES standard, and in the second figure B, the detail of individual iteration is indicated. Here the circle plus means exclusive OR. The operation of these intermediate stages is illustrated in figure B. Each stage takes two 32-bit inputs and produces 32 bits output. The left output is simply a copy of the right input. The right output is the bitwise XOR of the left input and a function of the right input and the key for this stage key. All the complexity lies in this function only. Here the function consists of 4 steps carried out in this sequence. Here first a 48-bit number E is constructed by expanding the 32-bit R, Li-1, according to a fixed transposition and duplication rule. Second, E and Ki are XORed together. This output is then partitioned into 8 groups of 6 bits each of which is fed into a different S box. Each of the 64 possible inputs to an SBox is mapped onto a 4-bit output. Finally, these 8 cross 4 bits are passed through a P-box. So such iterations are done and the algorithm before the starts of 56-bit transmission is applied to the key. So this is how data encryption standard works, iteration by iteration. Now next is advanced encryption standard, that is AES. So the more popular and widely adopted symmetric encryption algorithm which is likely to be encountered nowadays is AES, that is advanced encryption standard. It is found at least 6 times faster than triple DES. The features of AES are as follows. First one is symmetric key, symmetric block cipher. Second is 128-bit data or 128, 192 or 256 bits key. Third one is it is stronger and faster than triple DES. And the next one is that it provides full specification and design details. So these are the features of advanced encryption standard and it is better than DES. Also here the software implementation is also possible in C and Java. This is the diagram which indicates the advanced encryption standard. Here in this figure, the initial setup of 12-byte arrays of size 4 cross 4 is illustrated. There is one more step before the main computation begins. RK of 0 is XORed into state byte for byte. In other words, each of the 16 bytes in state is replaced by the XOR of itself and corresponding byte in RK of 0. Now it is time for main attraction. That means the loop executes 10 iterations, 1 per round, transforming state on each iteration. The contents of each round consist of 4 steps. Step 1 does a byte for byte substitution on state. Each byte in turn is used as an index into an SBox to replace its value by the contents of the SBox entry. This step is a straight monoalphabetic substitution cipher. Step 2 rotates each of the 4 rows to the left. Row 0 is read by 0 bytes. Row 1 is read by 1 byte. Row 2 is read by 2 bytes. And row 3 is read by 3 bytes. This step diffuses the contents of the current data around the block analogous to permutations. Step 3 mixes up the column independently of the other ones. The mixing is done using matrix multiplication in which the new column is the product of the old column and a constant matrix with a multiplication done using finite field. Finally, step 4 does the XOR operation for the key of round into the state array. Since every step is reversible, decryption can be done just by running the algorithm backward. However, there is also a trick available in which decryption can be done by running the encryption algorithm using different tables. This is how advanced encryption standard, and it can be said that it is far better than data encryption standard. It is the more advanced version. These are the references for this presentation. Thank you. Thank you for listening.